Hey, hi everyone. So today we are going to discuss about message queues. Message queues form an very important part of system design, and it's a it's an asynchronous communication protocol basically. And what it helps in usually is that two or more systems that have to interact with one another. Those systems can independently work when you have message queues, proper message queues in place. Message queues also help to safeguard against outages and failures. One of the prime reasons why message queues are so popular. And I think message queues, the famous, or the most commonly used ones are Rabbit and Queue, Kafka. Uh, in general, I think message queues, have been around for a while. And it helps to understand, I think, some of the terminology around message queues. Primarily, I think, understand like what are producers, what are consumers, and what are exchanges, right? So we're going to discuss that through this diagram and understand what exactly producers, consumers, and exchanges mean. Producers are nothing but your client applications that basically create the message. Your request origins can be basically any app, for example. Where you're saying like I want to create a document, or I want to convert a document, or I want to order a fruit from an online app, right? So request origin can be from any app, web or mobile app. And essentially consumers are like in this whole journey. If you look, consumers are the final part. In between there are a message, I would say brokers, that process the information and allow that information to be put in the proper queues. It'll make more sense if we obviously look at in an example. But message queues essentially allow systems to function independently and not to be blocked on waiting, let's say, for an output from, let's say, a previous system, right? So you can independently, for example, producers here, right? I mean, those systems, producer systems can generally send out a lot of messages. There'll be a lot of information exchange, and then those messages decoded are put it into the queues, and then I think finally the consumers actually act on those, right? So let's look at a classic example of an online ordering system like Zomato. So what happens in Zomato, if you try to just create an image of, let's say, three or four steps. There are users that are ordering food. User one would be ordering, let's say, fries, chips, whatever, right? I mean, and a lot of other users are ordering different food items, ice creams and whatnot, right? That is happening through the mobile app, right? Now essentially, if you break down this into three or four different systems that will act one by one, as in when these requests are actually fed into those, right? So user one is sending a request, it goes to the order processing system, wherein if the order is whatever, right? I mean, selection of the restaurant, and the user information, app identification, identifier, all of that, I think process, map the order to a particular user, and then send it back, and then allow for a particular restaurant to pick. So essentially, when you have millions of such requests coming in, right? You need to basically have an queue in place, right? Because otherwise, how would you actually have a system that is allowing for every user to be for every user to be attended, correct? So here, for example, order one coming from user one is then, I think, passed on into this queue, wherein you look at all the restaurants that can fulfill that order. The restaurants are going to accept it, right? And this this information goes here, and there's obviously some application that is running on the restaurant, and then that information is again processed back, right, to the queue, right. The next step in the queue is that you assign it to a delivery system, right. What that delivery system does is obviously it will find out, I think, who are the, like, the nearest delivery guys that are, like, maybe serving an order, about to complete an order, or are idle, right? So those delivery guys basically will also have some sort of queue in place internally, wherein those are actually picking, orders one by one. An order is obviously like assigned to, one delivery agent, and then finally delivered, and then you get an order completion message, right? This is how an online ordering system, will work. There are obviously like, parts to it, wherein, like, you ordered, let's say, some dish that is not being served, or is being served but not at the time, then those orders basically get rejected, right. Similarly, you might have processed the order because you felt that that order should go to bunch of restaurant, but the restaurant basically rejected that order for whatever reason, right. So it has still managed to pass through the order system, go to the restaurant, and then in that case, maybe the this order is rejected then and there itself, or maybe the order was processed, the restaurant actually like, picked up the order, prepared the order, and then finally you got the order, but you could not assign it to a delivery guy, right, or the delivery guy had basically declined to pick up, right, the order, right. So there will be that rejection, right. So a complete, I think, messaging queue will take care obviously of all of these cases, right. uh, we can argue about, like, what goes inside each of these system, and how are the message queues, like, helping the order prioritization, or the cooking by the restaurant prioritization, and how are delivery, like, I'm not getting into the details of that, because the idea is to make you understand how a messaging queue basically functions, what are the caveats, and what are, like, the questions that could come. So if you now understand this order system, right, it is acting independently or asynchronously, as compared to this restaurant, whatever, that is accepting the order, and then the delivery system, right, that is also acting independently or asynchronously, right. So you could have had, like, let's say, 10 orders coming in here, right, and maybe one restaurant is available, right. That one restaurant maybe can accept all 10 or can accept none, right, but that decision making of the restaurant, which is, like, let's say, online at the moment to accept the order, is independent of how many orders are processed, correct. And fine, also, like, the similar concept on deliveries, right. You might have the orders ready, but then you are not going to have a delivery guy in your neighborhood, or in your final destination pin codes neighborhood where the delivery is supposed to be present. There you're not able to actually find a delivery, right. So that system and the processing of uh, ready to pick up orders, right, though that is basically something that is independently or asynchronously handled by, like, this system, right. So keep in mind, I think message queue's biggest functionality is around asynchronous communication. Also, in some cases, you could argue that it's allowing for some sort of a temporary storage, right? Because there's 10 orders, for example, that have all been passed through the mobile app, are sitting somewhere, right? So queues essentially, like, are allowing you to store that information temporary, right? Purging obviously happens once the orders move out, to the next queue in line, and then those are, like, picked up, right? So I hope this gave you enough breadth to actually understand what are message queues. I would suggest that, okay, we can understand in the next part about RabbitMQ and Kafka. But I think, generally speaking, in system design, this should be more than enough if you were to be asked about, like, message queue. I hope you found this video useful. Please go like and subscribe to my channel. And in the next video, we will be covering load balancers. And I think there have been a lot of requests, I think, that folks have put in to actually cover a proper system, like, design, topic. So that is also going to be coming soon. I will plan to release that video wherein we will talk about uh, high level designs, low level designs, estimates, how a proper independent components like caches, load balancers, message queues actually function, and then have a full hypothesis and assumptions around that. So stay tuned for that. I'll be posting that very shortly. Thank you.